Okay, so now I'm going to go through the C06 example project in the class repository, translation. So let's really quickly look at what this does. Not too much. What is it doing? How's it different? Well, I'm pretty sure that one of the things that this can do is now we can have an actual model matrix that lets us move things around just like we were doing before. So let's go through the main. Main looks the same. Shader compiler looks the same. So let's look at app class and what's going on. Initialization is the same. Processing information, the constructors, they look good. The initialization looks the same. We're using basic and basic color.vs. So let's really quickly look at the basic vertex shader. And now, much like what we were doing towards the end of the messing around with shaders and math, we have this what's called an MVP, which is a 4x4 matrix, times our position. So what is this MVP? And if we look down, we'll see there's a little bit more stuff going on, right? So like before, if I hit one of these numbers, I'll change the color. But it looks like if I hit left, right, up, down, I can move this around the screen. That's pretty cool. So what's going on? Well, let's take a look really quickly. When I'm setting my M4 model equal to GLM translate 0.1. Okay, so what is the translate GLM? Translate GLM is actually what's called the translation matrix. So much like what we were doing before when we did it manually, it gives us back a translation matrix. Or you can have a rotation matrix, or a slow rotation matrix, or a scale, or whatever, ortho, whatever. All these matrices, lots of different kinds of transformations as you can kind of imagine. So what we're doing here is we're setting the model matrix equal to the translation of the model matrix with this other stuff, with a bit of a vector displacement. And so this is actually taking our existing model matrix and then applying a transformation to it, which is pretty cool. And that's really it. And then the only difference, now we're taking that MVP, we're getting the uniform location, and then we're setting our information to that. And we're taking a couple of new matrices here that we're passing in. You can see how we're chaining them together. Right now, the M4 view, this is sort of implied, but what's matrix 4? Matrix 4 is a definition we use for GLM matrix 4. So let me do you guys a little bit of a favor here. Okay, so that's really it. And this is really just GLM matrix 4. Right, that's what's going on here. And these will be valuable soon in that we want to know what's going on. So we have our matrix view, and we have the matrix model, and so that's where that thing comes from, MVP. But you're like, MVP, this is clearly PVM. Like, why is it called MVP? For the life of me, I don't really know. It's funny because what happens is if you think about the order in which the matrices are being applied, first you apply the model, then you apply the view, which is like my view. Well, I'll explain these kind of briefly and we'll talk about them further in lectures. And then you apply the projection. So what's going on? The model rotates the model into what's called world space. So imagine the universe and I'm putting Earth over here. Cool. And then the view puts that everything into respective of me, so my head is now in the middle of the universe. And so say in my example I put the Earth here in the universe, now I'm putting myself in the Earth, so like that's over here now. So it's like kind of has this negative uh, translation thing going on. And then the projection is the final transformation that we utilize to convert 3D space into a 2D projection, which is, imagine if you took a glass plane and put it in front of you, and then you just drew what you saw, right? You can take that and then look at it here, and it'll look like a flat projection of what you saw through that plane. The projection matrix does that, and there are a variety of different types of projection matrices, like orthographic or perspective, for example. And so, yeah, and that's really it, and it's pretty cool. So like, view and projection tend to have to do with your perspective in the camera, and then the model has to do with the model. So, for example, what if we added a little bit of a funky town guy? So like before we did, let's initialize our CDAR random thing here, and then let's M for model is going to be equal to GLM rotate M for model by, call it a what was it, RAM divided by RAM max. Generally you want to probably want to limit it to probably just wrap this up in something so you don't have to repeat it 20 times. Oh, and you need to pass it a vector. GLM vector 3 . Let's do it about the x-axis. Actually, let's do it about the z-axis so that we can actually see that happen. All right. Whoa! Crazy. A little bit too fast. Maybe 0.01. Now, you'll notice something interesting happening, which I really kind of want to point out to you guys, is you'll start to see a certain amount of what looks like almost distortion. And it's not distortion so much as it is truncation error. And it's gonna go in both directions, but we're not creating we're taking the same matrix and we're applying to it a transformation over and over and over and over again. And we're never normalizing that. And over enough time, like I think I was talking about this in a previous lecture, over enough time, the data, the matrix, will have a lot of noise, like small fluctuations in values and so on. So generally speaking, you do not want to hold on to internal state using a matrix, because you can see here the truncation error. It's almost like floating to the left a bit, the vertices are moving around. That's not the vertex data. That's simply the transformation matrix basically not coming back to zero. So you want to keep that in mind when you're creating some of the simulations that we may be doing, where say you're doing a rotation, you don't want to lump that into a matrix. You always want to kind of have values that you're converting from, like a rotation amount. So instead of doing this, what you really want to do is you want to create a normal this kind of thing. And say I want to do a float. Let me do a static float theta is equal to 0.0f, and then I do theta plus equals this value. So what's happening now is I'm saving my value and I'm creating a new rotation matrix off of origin each time. And now you'll see a lot less stuff going on, in theory. So yeah, I'm also not an expert, again, in the GLM, but you can kind of see the differences. Cool. Great. So now that's about it. This shows you, this is really exactly what we did before, except we're using some keyboard stuff, you know, what to do a little bit more and move things around, and we're getting kind of to the consolidation of a lot of these different ideas. Next, I'm going to start to dive a little bit into creating a mesh class, and yeah, stay tuned. More fun to come.